The Rutherford's model of atom said that in an atom, the most of the space in an atom are empty, and there is a nucleus which is positively charged, which is the center of an atom, and the nucleus contains protons and neutrons. And he said that electrons revolve around the nucleus in circular orbits in the atom. Okay, so this was the Rutherford's model. A nucleus having positively charged nucleus and like this circular orbits where the electrons revolved. Okay, so the nucleus contains protons and neutrons, and these are the electrons. So there will be equal number of electrons and protons, so the atom will remain electrically neutral. Okay, this was the Rutherford's model. So what did Rutherford's model say? Most space in atom is empty. The size of the nucleus is very small as compared to the total size of the atom. Okay, but the mass of the atom is centered in the nucleus. Nucleus is very small as compared to atom, but maximum mass resides in the nucleus. Okay, but this model had some drawbacks. What were the drawbacks? Drawbacks of Rutherford's atomic model. Okay, so the first point was the Rutherford's atomic model was very similar to the solar system. So what is there in the solar system? The sun is the center and different planets revolve around the sun in their particular orbits. So the atomic model also was quite like the solar system. Like the sun, here the nucleus is at the center, and if we consider the planets as electrons, then the electrons have orbits and they revolve around the nucleus in their specific orbits. But one difference was that the planets are uncharged objects, right? Like the Earth. Earth is electrically neutral, of course. So the planets are electrically neutral, but the electrons are charged particles. So they have charge. So what will happen? When they move around the nucleus, they will emit radiation because they will have acceleration. How acceleration? Even if the electrons have constant speed, but when they are moving in circular orbits, their directions are changing. So we know that the velocity will change with the change of direction. So the rate of change of velocity is acceleration. So what happens? Speed is a scalar quantity and velocity is a vector quantity, right? So speed does not depend on direction. But velocity depends on direction. So when the electrons are moving in circular orbits, their direction is changing. So the velocity will also change. So the rate of change of velocity, which is written as dv dt, is acceleration, right? Acceleration. That is the rate of change of velocity. Now, according to Maxwell's theory, the charged particles moving with acceleration will emit electromagnetic radiation. Okay, so when electrons will emit electromagnetic radiation, then they will shrink. So before that, let's see how the planetary model is similar to the electronic model. Okay, for the electrons, the force acting on it is K Q1 Q2 by R square. That is the electrostatic force. So K is the constant, Q1 and Q2 are charges between the electrons and the nucleus. Okay, so if Q1 is the charge of electron and Q2 is the charge of nucleus, and R is the distance between the electron and the nucleus. And for planetary model, we have this formula, Fg equal to capital G m1 m2 by r square. So in this case, G is the gravitational constant, m1 and m2 are the masses of two objects. For example, if m1 is the mass of the sun, then m2 is the mass of the earth, and r is the distance between the sun and the earth. So two formulas look quite similar. So this also proves that the atomic model and the planetary model were quite similar. But the difference is planets are uncharged, but electrons are charged. So this is the main difference. So what will happen by Maxwell's theory? We have read that charged particles moving with acceleration will emit electromagnetic radiation. So when the electrons are emitting radiation, their energy will be converted into radiation. Okay, so the energy of electronic motion is converted to energy of radiation. So the energy will decrease, that is the energy will emitted as radiation. So the path of electrons will shrink. Path of electrons will shrink. So they will form kind of a spiral path, like this is the nucleus. If at first the orbit was like this, after losing some energy it will come inside, and gradually as the electron emits radiations, orbit will go on decreasing. So kind of a spiral path. So gradually after some time the electron will collapse into the nucleus. Electron will sink into the nucleus. So the atom will collapse. So at this point Rutherford's atomic theory failed to prove this. Another point was, so now the question may arise, like if the movement of electrons is the problem, that is acceleration of the electrons are the problem, so why don't we consider electrons to be constant? Like if the electrons do not move, electrons do not move, it is the assumption. If electrons do not move, then apparently this problem will be solved. If the electron is not moving, they will not face acceleration and they will not emit radiation. So this spiral pathway thing will not happen. So what will happen if the electrons don't move? So we know that if a particle moves in circular path, there are two forces acting here. Okay, this is the nucleus, this is the electron. So between the nucleus and the electron there is the electrostatic force. This is the electrostatic force. And there is another force that is called the centrifugal force. What is the centrifugal force? This is electrostatic force and centrifugal force. What is the centrifugal force? That centrifugal force is a force that acts on a particle moving in a circular path and what is the direction of centrifugal force? That is away from the center, right? That is the center of the circular path. Here the center of the circular path is the nucleus. So centrifugal force will act away from the nucleus, that is outside. So Fe acts inside, centrifugal force acts outside. So these two forces, electrostatic force and centrifugal force, cancel each other. So the electrons stay balanced in its path. Now if the electron does not move, then there will be no centrifugal force. When there will be no centrifugal force, if there is no centrifugal force, only the electrostatic force will be there. So the nucleus will pull the electron towards itself. nucleus pulls the electron towards itself. Why? Because the nucleus is positive and electrons are negative. Opposite charges attract each other. So, nucleus will pull the electron towards itself. Then also the atom will collapse. So, this case, like assuming electron to be static, this is also not working. There was another crucial drawback. Another crucial drawback of the Rutherford's model was that the Rutherford's model did not state the distribution of electrons in the atom and their energies. Like hydrogen has 1 electron, helium has 2 electrons, whereas carbon has 6. Now, if we talk about some bigger elements like copper has 29 electrons, iron has 26 electrons. So, how are these electrons arranged? That Rutherford didn't say, because they cannot exist in a single orbit. If in a single orbit so many electrons are moving, then there will be a chance of repulsion because electrons are all negatively charged. So, this thing also Rutherford's model did not state. So, next we will study about what were the developments after the Rutherford's model. So, on these drawbacks of Rutherford's model, later on Niels Bohr proposed a different type of structure. It was not entirely a different type of structure. He modified on the Rutherford's model. So, Niels Bohr modified the Rutherford's model. Okay. So, what were all the drawbacks? All the drawbacks were that the moving electrons will emit radiation. So, gradually the path of the electrons will sink and it will fall into the nucleus. The second drawback was if the electrons do not move, then also the nucleus will pull them towards itself. And the third point was there was no statement about the distribution of electrons in the atoms. So, before studying Niels Bohr's modification on Rutherford's model, Bohr's model was based on two things. They were based on many factors, but the most important factor was dual nature of electromagnetic radiation. And some other experimental results. So, next we will study about what were the pathways that led to the Bohr's model. There were some backgrounds which led to the Bohr's model. We will discuss them now. Thank you.